Hello everyone. Today we are going to go over cube radical equation. So in the previous lesson we learned about just radical equation in general, but in this one we're going to learn about cubic radical equation. In our radical equation lesson, we learned that in order to remove a radical, we must square on both sides. So the reason we square on both sides is because the index of a square root is 2. So let's take a look at the following example and see what I mean by that index situation. So if I rewrite radical x as like a rational exponent, it becomes, so let's see, this is 1 as the power, and then we have our index is 2. So technically this is like 1 and there's a 2. So using our rational exponent rule, technically this is 1 over 2 is equal to 7. So when I square on both sides, I'm able to remove that exponent of half because 1 over 2, so let's see, 1 over 2 times 2 is equals to 2 over 2, which is just equal to 1. So we're able to cancel them out. So that's why if I have just a radical 7 situation, we square on both sides and we get x is equal to a 49. And if you want to like see it from the other point of view too, is the same exact situation. Radical x is equal to 7. We square on both sides and we end up getting that x is equal to a 49. So this idea also we are going to apply when we are working with cube root. The only difference is instead of squaring both sides, we will use the cube or put it to the third power on both sides. So let's take a look. I'm going to show it two different ways here as well. So let's see. So the reason I'm going to show both ways is so like you are able to make that connection again. So rewriting it as an exponent is x to the power of 1 over 3 because this one has an invisible 1 as the power is equal to 4. And once again, when I cube it on both sides, I end up getting 1 over 3 times 3, which is equal to 3 over 3 is equal to just 1. So we end up getting a x is equals to 4 to the power of 3, which I believe is a 64, but I'm going to use my calculator to double check, and that is 64. Okay, and same idea if you use your calculator to remove a radical cube root of 3, you would get x is equals to 64. So there we have it. So let's apply it to like a little bit algebraic situation where we have a cube root of x minus 1 is equal to negative 4. So same thing, we're going to cube it. And if you want to rewrite it as an exponent of 1 over 3, you can. You don't have to. So we have, after cubing it, the cube root is removed. We have x minus 1, and negative 4 to the power of 3 is negative 64. So I add 1 on both sides, and I end up getting x is equal to negative 63. Now we must check our work. So we would do a cube root of negative 4 minus, negative 63. Negative 63 minus 1 is equal to negative 4. And let's see if we end up getting a true statement for this. I'm going to grab my calculator on the screen so we could see it. How to put it into the calculator too. So let's see, let's clear our calculator. We press math, and then when we scroll down, we see a cube root, and then I'm going to put negative 63 minus 1, and then we hit enter, and we do get a negative 4. So we have negative 4 is equal to negative 4. So it does work out for the check. Let's take a look at the next one. We are going to cube both sides again to remove the cube root, which leaves us with x squared plus 5 is equal to a x squared minus 4x plus 1. So right now it's looking like a quadratic situation, but I think we can take care of that by canceling out the x squared here, and it works out perfectly because both of them have the same exact coefficient. So we were able to cancel them out. We're left over with 5 is equal to negative 4x plus 1. I minus 1 on both sides, left over with negative 4x is equal to a 4. Divide by negative 4, divide by negative 4, x is equal to negative 1. But once again, we must check our work. And this one, excuse me, I will show you here. We have cube root, let's see, negative 1 square plus 5. Let's see if that's equal to cube root of negative 1 square minus 4 times negative 1 plus 1. Okay, so let's see. We press math, cube root, and then we're going to put the negative 1 inside parentheses. And that gives us a 1.817 dot, 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 dot. Let's see if we also get that on the right-hand side. Press 4, and then we have negative 1 square. And then we have minus 4 times negative 1, and then we have plus 1, which is also equal to a 1.8171 dot, 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 dot. Okay, great. So the check worked out, no extraneous root. All right, make sure you jot down all the notes, and if you have any questions, you could bring it to class.